myself. Today we're going to be looking at quotient powers of properties. It's going to start out relatively simple with a new idea, and then we're going to use the ideas we've already learned to build on our ability. So we're going to start by writing down this definition. Make sure you're writing down numbers in algebra so that you have a really good understanding of what it is that we're going to do today. Okay, so let's look at this now. So I don't need you to copy the table, but I do want you to write down what we're doing. Okay? So when we do exponents, we're calling it, it's a way of saying repeated multiplication, right? So I'm going to put a fraction bar in here. And I'm going to write out my exponents, my numerator and my denominator, as repeated multiplication, okay? So this is going to be 2 times 2 times 2 times 2, because that's 2 to the 4th power, right? And my denominator, my bottom part, says 2 squared, which is 2 times 2, correct? Now, I want to solve this or simplify this and put my answer over here in the form of a power. When I have powers with the same base, everything is a 2, right? Eddie, pay attention. I can simply eliminate my pairs like this, right? So do I have anything left in my denominator? No. I still have my base of 2, correct? And what is my power now? If there's 2 2's, what is my power?
4.
Nope. 2, right. This is 2 to the 1. This is 2 to the 1. What's 1 plus 1?
2.
So my power is 2. Right? Pretty simple?
Well, sort of.
Yeah. We're going to do another one, just like we did here. I have negative 4 to the 5th over negative 4 to the 2nd. So I'm going to write negative 4 times negative 4 times negative 4 times negative 4 times negative 4. Okay? So that's 5 negative 4's, right? And on the bottom, I'm going to write 2 of them. Negative 4 times negative 4. And then I'm going to go ahead and do my elimination, right? I'm going to eliminate these 2 pairs, because that becomes 1, right, if I'm dividing. I'm left with my same base. What is my base?
-4.
So my base is going to be negative 4. And how many of them am I left with? 3. And there's nothing in my denominator, so I don't have any, it's not over anything, but it's to the 3rd power. Easy peasy lemon squeezy. So I want you guys to go ahead and do this next one, 7 to the 7th over 7 to the 3rd on your own in this next row, and then we'll check it in a few. So go ahead and do the next one. All right. So what did we get? What did you guys end up with? 7 to the what?
4 power.
Right. Let me show you something. So while you guys were doing repeated addition, there's a little trick here. Right? So my bases are the same, so I know my base is going to be 7. My numerator is 7. It's the bigger number, right? So if I just subtracted this 3, what do I get? I get 7 to the 4th, right? Isn't that the same answer that you guys got?
Yes.
Yeah, so that's my little alternative here. So let's look at the next one here. I have 8.5 to the 9th over 8.5 to the 6th. Do I have the same base?
Yes. Yeah.
Yes, right? So I can say 8.5. I'm going to start with my bigger number, my numerator. Can I subtract this 6? Yes. Oops. And what do I get? To the 3rd, right? Because 9 minus 6 is 3. Same thing. Okay, same process. 2 different ways to cook this egg, right? We can scramble it, or we can just do it over easy. It's whatever works best for you. There's no right or wrong. The only thing that I want to see when you do your homework is I want to see your process. I want to see how you're getting to your answer. Don't just give me an answer. Show me the process. Okay? Understand? We're going to move on a little bit, and just using our inductive reasoning, Here is the actual rule for this problem. So I have a to the m over a to the n. Do I have the same base? Are they both base a? Can I write something up here that'll get rid of this division bar? What can I write up here? Absolutely, m minus n. That's my rule. Okay, and you guys should have written that down in your notes already. And this is where you're applying that thought. So even though here I have a bunch of numbers, it's not always going to be that way. I can, at some point, end up with exponents that are variables or a base that is a variable. Okay? So everybody have this copied down? All right, we're going to look at just some other simple stuff here. Oh, actually, no, I lied. I'm a liar. On your own, I want you guys to solve problems 1 through 4. You're just going to simplify it, just like we did. You're going to do 1 through 4 on your own. I'll give you a few minutes to do those. All right, so let's quickly go over and see how sharp you guys are from the tool shed. Okay, so remember I told you I wanted to see your process, right? So the process that I like is doing the multiplication. I like to say 9 to the 7 minus 4. Okay, that's one way. How many of you guys like that way best? Okay, so that's okay. So what is 7 minus 4? So that means my answer is 9 to the 3rd, right? But that doesn't mean that doing the fraction bar and doing this is not right. Okay, this is also correct. This is also 9 to the 3rd. Okay, either way, whatever, oh, you can't see. Either way, whichever way makes more sense to you is fine with me, but I do want to see the process. I want to see how you got to that answer to make sure that you understand the concept and the process. Yes? Okay. So for number 2, Jordan, how did you do this one? Okay, so you started with your base of 4.2 and did 6 minus what? 6 minus 5, which gave you 4.2 to the what? To the 1. Okay. Here's something I want you guys to remember. If I don't put a 1 there, it is understood that the value of this base number has an exponent of 1. I'm not going to put the 1 there, but I want you guys to remember that, okay? If there's no exponent, what is the exponent that I could put there if I wanted to? Juan. Remember Juan? He's shy, so we're going to let Juan hide, okay? But he's there. He's just hiding, okay? Remember that because that's going to be important in a bit. Okie dokie. So let's go ahead and look at number 3. Matthew, how did you do number 3? Did you do the fraction bar or did you do a subtraction? So you went ahead and wrote 8/8. Over 4/8? But they're negative, right? It's just easier if I do them like that. Okay, and then you crossed out how many?
4.
And what were you left with?
-8 4 power.
Yes. Okay, you could have also just did 8 minus 4 equals 4. Okay, either way, I want to see the process. Okay, so for the last one, Tiffany. No, actually, Laudo. The last one. I have x to the 8 over x to the 3rd. How did you do that one? Which gave us? Right? Got it? Yes? Easy peasy lemon squeezy? All right, so let's look at this one down here. Okay, I want you to copy down this problem. In fact, I'll copy it down here too so that I can work it with some space. We're writing that problem down. I can still do the same thing that I've been doing right now, but I have to use some of that information that I've already done from 10.1 and 10.2. So what am I going to do to these two exponents in my numerator? I'm going to cover up that denominator. Am I going to do what? Times them? I'm just looking at my numerator right now. What am I going to do, Hannah? I'm going to add them. So I'm going to say 3 to the 4 plus 2. Am I adding anything here? Can I just bring this 3 to the third over? Just bring it over. Thanks. Somebody's paying attention. So when I add 4 plus 2, what do I get?
6.
So this becomes 3 to the 6. And I'm just going to bring over my 3 to the third, right? Now I can do something with my denominator, right? Do they have the same base?
Yeah.
What's my base going to be? So what am I going to do to these exponents now? Now I'm going to subtract. And my answer is 3 to the third. Right? So that's just using that prior knowledge, that information from 10.1 to solve this problem. Yes? Yes. Okay, I want you guys to do a couple like these on your own. You're going to do problems 5, 6, and 7 on your own. You're doing 5, 6, and 7. I'll give you a few minutes. I can see some of you getting confused. If I extend this fraction bar and just put a multiplication there, it's the same problem. It's just like this, okay? If I extend this fraction bar and put a 0 here, a multiplication there, it's the same problem. Okay? They just wrote it a little bit differently. Don't be afraid.
So since D to nothing, that would be D to 1. Okay.
Yes, you remember. All right, so let's look at these. This time I have to look at my denominator, right? My bottom numbers first, right? So in order for me to be able to solve this, I'm still going to have a fraction bar. But I'm going to bring this 2 to the 15th over because I'm not doing anything to that. But I do have to add some exponents down here. It's still the same base, but I need to add them. Why am I adding them and not dividing or anything else? Because it's simply multiplication, right? So 3 plus 5. Okay? So that gives me a new problem. I'm going to keep going over here where I have more space. Okay, it gives me 2 to the 15 up here. And what does it give me on the bottom? What's my bottom? 2 to the what? 2 to the 8th. Okay, and now I can continue my problem, right? By saying I have, get rid of my little fraction bar here. It wrote too much. So my base is 2, correct? So I'm going to bring that base over. What is 15 minus 8?
7.
So it becomes, sorry, choking, 2 to the 7th. I choked because Laudo had the right answer. Just kidding. All right, I'm good. I'm going to live. All right, so let's look at number 6. How many of you guys got 2 to the 7th for number 5? Excellent, 2 to the 7th. All right, so let's look at number 6. All this does is make 2 fractions, but you still have a top and a bottom. So we still want to go ahead and add our exponents. So I'm going to add a new fraction bar. My base is D for both of them. I'm going to add 5 plus 9 on the top. And what am I going to add on the bottom? This is where I was trying to make it really tricky for you guys. What is the exponent of this D? There's a 1 there, right? You need to remember to add that 1 plus 8. Okay? It's not d to the 0. It is d to the 1. Okay? So we're going to say 1 plus 8. So my answer is going to be, what's 5 plus 9? D to the 14th over d to the what? 8 plus 1 is 9. Okay? No, I added these. So then I have the same base, right? So this becomes just d. What is 14 minus 9? D to the 5th. Took a little bit more work, right? First I had to combine them, come up with my answer, and then do my subtraction. Same thing applies over here. This becomes a fraction. 5 to the 9 plus 5. 5 to the 4 plus 2, right? Which gives me 5 to the what? 14?
Yeah.
Over 5 to the 6, right? Then I get a 5 to the 14 minus 6. And my answer is? Yes? Any questions, comments, concerns? Should be relatively simple. Your homework is on the board. Mr. G is going to pass out the papers to you. I know most of you have already turned in your books. So I went ahead and made a copy of the pages that you need. Make sure you only do what you need. If you want to do more, that's fine with me. Start your homework. Most of first period finished their homework in class, so I believe you guys can too.